Good morning, Chem. Today we're going to introduce molarity and dilutions. So, molarity is a unit that describes solutions. A solution is more common than you think. Most things are solution. It is a homogeneous mixture of two or more substances. So, typically, when we say homogeneous, we mean that you cannot see the different pieces and parts. They're mixed together in a way that makes them look like one substance. So it's made up of the solute. The solute is what is being dissolved. So that's the substance that is present in the smaller amount. And then the solvent. The solvent is present in the larger amount. Water is considered the universal solvent because a lot of solutions are dissolved in water. So even tap water that you get out of your faucet or out of your fridge, or even the bottled water that you drink is actually a solution, meaning that it's not just H2O in there. There's other things dissolved in there that we can't see, making it a solution. A soft drink is a good example. A soft drink is a solution that has the solvent water, and the solute or the stuff that's dissolved in it is like sugar, food coloring, carbon dioxide is what gives it the bubbles. And notice when it's in the bottle, you can't even see the carbon dioxide. Not until you open it, that lets that carbon dioxide get an opportunity to escape into the atmosphere. Air is another common example of a solution that's a solution of gases. So it doesn't necessarily always have to be liquids. And air consists of a bunch of stuff together. We cannot see the different pieces and parts. Nitrogen is the largest component that makes that the solvent. And then the solute are the things in other things in there are oxygen, argon, methane, so on and so forth. Main component of air is nitrogen. Next is oxygen. Then the third largest component is argon. You also have methane. You also have other greenhouse gases like carbon dioxide and sulfur dioxide and nitrogen dioxide, so on and so forth. So here is a particle picture. If you looked close with a microscope, you still wouldn't be able to see it, but here's a particle picture of what solutions look like. So the general properties are a solution is a homogeneous mixture of two or more substance. Substance present in the largest amount is referred to as the solvent. And when we say amount, we're referring to the unit of moles. The other substances present in smaller amounts are called the solutes. A substance that dissolves a particular solvent is said to be soluble in that solvent. So solubility is a measure of how much will dissolve. So let's say you're making a saltwater solution. The solvent would be water, and then salt would be the solute, and it would be saturated when you fit as much salt, dissolve as much salt as you possibly can. So let's talk about the concentration. We're going to measure concentration in a unit called molarity, which is big M. That stands for molar concentration. That's defined as the number of moles of solute per liter of solution. The solution is the solute plus the solvent. So that's the final volume after all the pieces and parts are in there. We can also rearrange this just by taking that formula and putting the units where we want to. So if we're solving for liters, it would be moles over molarity. If we're solving for moles, we would rearrange it and it would be molarity times liters. So those are the three possible arrangements that you could want to use with this basic formula. Let's look at an example. For an aqueous solution of glucose, remember aqueous means dissolved in water. Determine the molarity of 2 liters of a solution that contains 5 grams of glucose. So we put what we know about the solvent on top, what we know about the solution on the bottom. Sometimes you might have to add the solvent plus the solute. You have to be careful. about the wording. This tells us that we already have the solution, so we can put that right on the bottom. It's in liters, just like we need it to be, so that's fine. On the top, however, goes the solute, and that's the glucose is in grams. We need to change grams to moles. We do that the same way we've always changed grams to moles, using the molar mass. If you pull out your mole card, you will see that there is a box on there, a brand new box that we're going to use, that is called volume of a solution. So we already used volume of a gas. Now we're going to use the box that says volume of a solution. So let's change glucose in grams to moles with the molar mass, and we get that we have 0.277 moles. Now we'll just divide that by the volume, and we get a molarity of 0.139. Now let's do a different kind of problem where we solve for the volume. So remember, if we rearrange the equation, the volume is in liters, you can just swap the spot that liter and molarity have. So we can say that volume equals the number of moles over the molarity. And our last part of possible problem could be the number of moles. If we're solving for the number of moles in glucose in 0.500 liters of the solution, moles is going to equal the volume times the molarity. And we multiply that in our calculator. So those are 3 different types of problems that you might have to solve. So just remember, if you're given grams, change it to moles. If you're given milliliters, you change it to liters. So you just have to make sure that your units match. Now, when we're doing problem solving, remember, it is very important to decide whether an answer sounds reasonable. So if you end up getting a huge number or a small number, super small number, you need to double check your thinking. This is how we prepare. This is a piece of equipment called a volumetric flask, and I will show you how to make a solution. What you do with a volumetric flask, it's a very accurate measurement and calibrated piece of equipment. The marker is very calibrated and very accurate, and the neck is very small in order for you to be able to read exactly on the line very carefully. So what you do is you first put your solid in there after you measure it carefully with a balance. Then you add about half of the water that you're going to need to dissolve it. So you're going to stir it and shake it. And once everything is dissolved, you're going to fill all the way up to the top. You're going to use a squeeze bottle or a dropper to make sure that you can get it exactly to the line. You read to the bottom of the meniscus, and this is how we prepare solutions. Now let's talk about something called dilution. If you remember, we touched on this when we learned things that speed up a reaction, such as concentration. A dilution is when you add more water. So when you dilute something, the volume always ends up being greater and the molarity always ends up being less. So when you're diluting something, you're taking it from being more concentrated to less concentrated. You can think of this like if you made lemonade at home. If you've ever tasted some lemonade and you've said to yourself, wow, that's pretty sour. It's too strong, but what you really mean is it's too concentrated. So you would know instinctually that if you wanted to make it less concentrated or less what you called strong, you would add water to it, and that's actually doing a dilution. Whatever the solvent is, you add more of it. Most of the time, that's water. So let's look at an example problem. How would you prepare 60 milliliters of a 0.2 molar nitric acid solution from a stock solution of 4.00 molar HNO3? So whenever you see molar, that's going to be your concentration. Whenever you see milliliters or liters, that's going to be your volume. Our formula is M1V1 equals M2V2, or MIVI equals MFVF. That's initial and final. Remember, let's call the less concentrated final volume and final molarity always. So the initial molarity was 4. The final molarity we wanted to get to is 0.2. So I'm going to say that my smaller molarity is going to be my final molarity. So we're going to be solving for the one that we don't know is initial volume. So look at what I did right away. I took the volume of 60 milliliters and I changed it to liters. You don't always have to do that, but if you get in the habit of doing it now, it's going to be so easy for you to switch back and forth. There's 1,000 milliliters in a liter, so you're going to move the decimal point over 3 decimal places. So I always rearrange my formulas before I plug the numbers in. And the reason that I do that is because then the units will tell me whether I've made a mistake or not. If my units do not cancel out correctly, that means I've probably made a mistake. And that's your first way to check if your answer is reasonable. If the units don't cancel, you don't have a reasonable answer. If the units that you want to solve for are on the bottom and they should be on the top, you also have a not reasonable answer. So I just plug this in and the answer is 3 milliliters. So how would I prepare this? I would take 3 milliliters of 4.00 molar nitric acid, and then I would add enough water to have a final volume of 60 milliliters. So I'm not adding 60 milliliters to it. I'm actually adding 57 milliliters to a final volume of 60 milliliters. And that's how I prepare a solution with a molarity that I want. If you got a job as a chemist, this might be a big part of your job. It's still even a big part of my job as a chemistry teacher, because if I want a particular molarity, it's cheaper for me to buy concentrated solutions and then just make the solutions that I want. It costs less money. And that way, I always have access to whatever concentration I decide I want. I can always take a more concentrated solution and dilute it down to whatever solution I want. Here's another example of a problem. If 32 milliliters of a stock solution of 6.5 molar sulfuric acid is diluted to a volume of 500 milliliters, what would be the resulting concentration? So in this case, we are looking for the final molarity, or M2. So this is, I use MIVI in the first problem equals MFVF. So you can see that they're both the same formulas. And that way, if you see it one way or the other, you won't get confused. Let's use M1V1 equals M2V2. That's what you're going to see me use more often. I'm solving for M2 in this case, so I can plug in the givens for the other values, and I get an answer of 0.42 molar. Now, let's talk about what's reasonable here. We had a smaller volume, and we diluted it to a larger volume. So we would expect the molarity to go down, and it did. The good thing about these problems is if you're making a mistake, they won't make sense. So dilution is the process of preparing less concentrated solutions from more concentrated. So you can see we can actually measure the concentration with the color. And there are pieces of equipment that scientifically measure how much color is in a solution. And those values are called absorbance and transmittance of light. Let's make sure we recognize, though, the number of moles in the solution stays the same throughout your dilutions. In an experiment, student needs 250 milliliters of a 0.100 molar copper chloride solution. A stock solution of 2 molar is available. So we need to recognize that the 2 molar is more than the 0.1 molar. So the 2 molar is what we're going to start with. That's going to be my M1. So that's the concentrated molarity, and the D, so that's what C stands for. The D is the dilute molarity. Plug in what's given to us, and we solve for 0.0125 liters or 12.5 milliliters. Notice Milliliters is a smaller unit, liters is a larger unit. So the larger unit's going to have this smaller number, and they're going to differ by 3 decimal points always. So if I'm going from liters to milliliters, I change my decimal point or move it 3 to the right. So to make the solution, I'm going to put 12.5 milliliters of stock solution into a 250 milliliter volumetric flask, and then I'm going to dilute by adding water carefully to the calibration mark. So this is an introduction to molarity and dilutions, and your next step would be to go and practice some of the problems that are given to you as an assignment.